Good morning and good afternoon. My name is Norman Clark. I'm a field applications engineer at Electro Industries, and this morning I'll be covering the Nexus 1500 meter advanced topics. So the three major topics I'll be covering are the power quality and alarms, historical log configurations, log viewer, and waveform recording. Before we get started, I will switch from my PowerPoint presentation, and I'm just going to launch a connection to the meter. So let's take a look. So I have a meter in my office that I'm connecting to, and it's a 1500 plus, and I'll just start the connection. When you first connect to the meter, you get the device status box. The first box here, device ID. Typically, we put the serial number in that field. The device type, it's the Nexus 1500 Plus, and also the serial number. As you see, that device ID is very similar to the serial number. On the right half of the screen is the firmware versions and what option cards are installed in this type of meter. So I'll just click OK at this point. So we're just going to jump right in and go right into the profile settings of the meter. You can access that from two locations, from the profile icon, or you can access from the current device profile. So we'll just click on device profile and let's get started. So the screen that you see is the CTPT screen, which is basically, I should say, all the screens that you see there are all the general settings, the revenue settings, all the screens that you'll need, or programming areas that you'll need to address when you program the meter. So the very first step we'll take a look at is the CTPT ratio. So this is one of the most important things you need to set up. Obviously, you need to know what your CT is you have installed, NPT, and this is configured for 400 to 5 CT. The neutral current, typically we set it at 5 to 5. This is a 120 configuration, and you would normally set the voltage again to match it for the aux loading. The hookup that we have here, there are four options, and there's the Y, the Delta 3T or 2CT connection. There's 2.5 element Y connection, and the four wire Delta connection. So the 3 element Y configuration requires 3 line to neutral voltages and 3 phase currents. That's very common. The second line is the 3 CTs or 2 CTs. Out of the 2 CTs, we know is the 2 CT combination is the most common application we find. And this configure requires a 2 line to line voltages. And typically we have VA, B, and VCB connected. And B would be the reference. And the respective currents would be IA and IC. 3 CT is the same configuration, 2 lines, other than it, except it has an additional 3 CT, but they're 2 same line-to-line voltages, again with an additional CT that's in the circuit. And then you have the 2.5 element meter Y. Or Y configuration, and this configuration is used when there are 2 PTs connected to a neutral type connection. And then the 4 wire Delta is the final choice. These are usually connected on power and lighting loads fed from a Delta source. So this meter, I believe, is connected as a Y connection. In the operational frequency range, you have 45 to 69 hertz, so that covers all 50, typically 50 and 60 hertz. So if I click OK here, what I see is the device profile limit waveform full scale, but basically it's providing the CT, the primary CT is 400 amps, and here we have it as neutral, but the VAN, VBN 120 volts, and it phase-to-phase voltages, if it's a Y that we have, and 120 is a neutral, is line to neutral. We have reported in this basically a power calculation, and that's the V times I, and the total power and so on. So these are your limits that you'll use later on. So let's take a look at the waveforms. So we'll jump down to, sorry, we talked about the limits. So we'll jump down to the power quality, and we'll see how that applies to, the limits that we talked about a minute ago. So when we're looking at the power quality section, what we see are high-speed voltage current, voltages, VAN, VBN, VCN, the high-speed IA, B, and C, and the limits that we set, the set points, 120%. Typically, folks will use 10% above and 10% below as your set points, and this is where you would make your changes. You have 32 that you can assign up to that you could choose. In this particular setting, we only chose 6 limits. Before I leave that section, I wanted to say that we set up the triggers to set up the alarms for each user, and we have to make sure that the CTPT is set up first. So it's something that we cannot overlook prior to setting up the limits here, because it kicks off from that information. So let's look at the logic. So the logic, electro-logic control settings that we have here allows the setting alarms to be used in some form of a logic tree to control meters externally. And this is an optional feature that Electro Industries provides. The initial input are chosen on limits, based on limits previously discussed. And basically you use logic statements and or in this as an example to produce true or false conditions. And for instance, like if you have AND gate condition, which you'll have both inputs are true, it will pass basically. And you can decide how, the flexibility, how you want to use this, if you want it true to be, the limits to be true or false. Again, this is an optional feature that you could purchase with the meter. So here we are looking at the waveform and triggers, and I'm sorry, voltage interruption settings. And there are voltage, these are basically voltage RMS triggers. Then there are current triggers and the voltage and transient triggers to choose from. You can set up these set points to choose whatever settings that you want. So if I could just tab right through voltage RMS triggers, current, and voltage transients. And again, you set the parameters. You have to enable these to take place. And after you've done all of this, you would perform an update in the meter. The meter can sample up to 1,024 samples per cycle. And with that, you have the flexibility of getting very high resolution, but you don't have the flexibility of having an extended period that you can capture. So you're limited somewhat when you use the higher or faster sampling rate. Okay, the meter complies with the power quality standards, IEC 61000 and EN 50, or make that 50160. And basically, these address measurement methods, the formulas and the accuracy and so on. Also addresses the power quality, which is one of the examples would be flicker for, I think it's 95% of the flicker rating that it recognizes. But basically the meter complies with these standards, and this is where you would set those values. So then you have the harmonic distortion and interharmonic distortion. And this is where you can set up certain values or a certain percentage of harmonic distortion that you want in the meter. The I squared T and the V squared T functions are selected when you want to set up trigger alarms for I squared T, for instance, catch inrush currents, or volt square T for capturing voltage spikes. And this checks for energy and current inrush currents, as I said. And a big case for this is where you may have circuit breaker failure constantly, or fuse being blown periodically. This will help you troubleshoot that particular problem. And most of the sources of the problem typically will come from a motor coming online with a very large inrush. So this is where you may want to set up the I squared T function. So okay, this line here, it's just the total demand distortion value, and this is recommended for capturing harmonics and things like that. It's part of your harmonics calculation package that they put together in this meter. But you would choose your voltage and current values after looking at the min and max polling screens. So you get those values from that screen. So your high-speed inputs. There are 8 high-speed inputs, and you could basically look at these. Let me see. I could drop down. So you have 4 options that basically can use for setting these. The first one is a KYZ input, and the KYZ input just allows you to attach pulse outputs from another meter, or meters or recorders, and this basically just counts pulses and totalizes those values. Then there's a PQ waveform trigger, and which allows you to trigger on waveform and power quality functions. I guess that's also tied to your limits and so on. So these are trigger based on those. This the name field, you can just basically label that particular point that your meter or source that you're bringing in, and that's a value that you would put on that line. So let's see, we looked at this. Okay, and so we talked about the waveform and the KYZ, and then there's also something called a block window sync pulse. This option allows you to sync your meter with the input pulses coming in from into that port. And then the last one, you have event trigger log option, and that's used to trigger logging when the state changes from open to close. So you have these two conditions. So we're pretty much satisfied here. We're move forward. Let's see if we can get this. Operational status. So the operational status lets you assign a relay to indicate the meters. The meter that you're looking at is operational when the meter boots up. So this is it's basically a relay that can be monitored by another connected device, and you have up to 4 input pulse relays that you can have connected to this meter. This is a power quality meter, so it's very heavy focus on power quality, and so it's lots of different features that it offers that you probably wouldn't recognize in most any other meter. It's just a very powerful meter. Take a look at the short term. So the short term max, min, and average and interval, it allows you to capture short term high and low readings on voltage that would normally you would not capture. So with this feature, you can capture the highest and lowest anomalies and then label them to trend the voltage quality over time. You can choose voltage type and corresponding historical log, as you can see. So the voltage reading type here we have is 1 cycle updated. We have 10/12 cycle updated, 3-second updated, and 10-minute updated. And this you would map it to a log in the historical log, and these are the choices that you can choose from. So let's jump to trending. Trending is where we store interval data in the meter, and I'll start with the trending log. Here we have the log size. So this meter has 6 log intervals that you can program to store different interval sizes. So this meter is set up for 15 minutes for log 1, log 2, 15 minutes, and so on. It's all the way through, and then you have log 7 and 8. So these are basically tied to another, it's the EN50160 type device. So that would be logged into that. So that's a waveform capture and power quality stuff that you will be stored in that log location. Okay, so here we are in trending, and we're looking at the different logs that we talked about. And so here we can look at measured values, and these are, volts, VAN, BN, CN, and the currents, and so on. This is something that you could program in log 1, or any of the logs if you want to look at voltages and currents and so on, power factor. This meter is programmed for log 1 second updated volts VAN. So here we have averages is the next choice that we have. We could enter these values and choose from our drop down. Here we have a thermal average, maximum thermal, all these different choices you could choose from. And it sort of limits what you can, as you select some of these, you can see it limits what options you have based on the group heading. If you look at accumulators, this is where the data is stored, the bins with the energy values. So this is a location where you would want to store your energy values for accumulators. And interval accumulators, again, this is all energy values. When you choose secondary values here, you notice KYZ option pops in. So here you can actually program KYZ using secondary. So the meter comes with a built-in KYZ board. So you can set that up to count KYZ pulses. That typically you can export out to another device providing pulse output through the KYZ. So log 2 is set up for, in this meter, energy scaled values. And so what we're going to do is take a look at log 2. We're going to do a data retrieval, and we'll take a look and see what it looks like. This is pretty much the profile settings, the power quality, and the limit that we talked about. So we're going to exit the profile at this point. And let's retrieve the logs. So when I click retrieve logs, I have this box that pops up, and here I could choose from a list of historical logs. I have also power quality. I have transients, a whole bunch of things I could choose from. What I did prior to this starting the session, I actually retrieved logs, and because it's a lengthy period of this particular meter, it's just so much data that's bringing in that it took considerable amount of time. So for the sake of getting through this the presentation without having you wait for the data to come in, I actually have the log viewer. So part of the process is once you schedule the log retrieval, it will open up after the data comes in something called a log viewer, and this is what allows you to view the data that you've retrieved. And so this screen pops up with the date, range, and basically the data points that you can choose from. Now I went in and I manually picked from my pick list here these 4 values, watt hours delivered, receive, hours delivered, receive, energy, scale values, and that we saw in log 2. So this is something that I had prepared in advance, and you can set these by default. You can always add other values as you want to, but for now, what I did was I really just wanted to look at these 4. So it's really a menu of things that you can view, but you do have to select the logs that will have those quantities that you just brought in. So let's take a look at this. So let's start with, let's look at the historical log, the trends first. So what you're seeing here in this meter are the retrieval data points that I brought in. And let's see, this goes back, this is up to 2:15 this morning. So this is data that was posted. It's very small load, but this is all the energy values that was brought in for that scaled energy value. So I can bring that into a spreadsheet by right-clicking on the left side of the screen, and as you can see, everything is highlighted. Then I would open up a spreadsheet and post that information in. And basically, this is the data that we're viewing right now in the log viewer. So this basically captured everything that we saw on the screen into a format. This is the serial number or the device ID, and This was a meter that I had brought in actually earlier. So again, um, this is another way of viewing the data from an export from the log viewer. So I will close this and let's take a look at, let's do, sorry. Let's open the log again. So this is the meter that I was looking at. And what I want to take a look at, we just looked at historical trends. I want to take a quick look at waveforms. So when we went to the trouble of setting up all the power quality and waveform triggers and limits, this meter had captured some events on the 27th during it's a few events going back to May of 2019. So it stores all the events. The meter does not erase the events. So these are waveform captures that was performed. And so we could take a look at the most current one and we see a voltage surge on the D phase. So we could just double click on that. And so here we have VBN, VAN, VCN. We have our currents. I could view those. If I could get, so just get an idea of what I'm looking at. All three voltages are overlapping each other. And this is just a quick snapshot of what the waveform capture looks like. But you could really do a lot of work and see significant issues using this as a troubleshooting tool. So it's an excellent source, and you can always export the files into a, on my screen, I'm having a little problem because my taskbar is right there, but you can export into ComTrade or PQDIF format this waveform. Okay, let's see where we are. So that completes the logging feature of the meter. One of the things I wanted to touch on is when you do a data retrieval and you retrieve the logs, the data comes into a location. You store that file. You have with the software options to choose where you want to store the data. So from time to time, we'll get a call from someone who is having trouble interpreting the logs, or they may have an issue with the data. So when you set up your path in the meter, you would set it up in the field. For instance, retrieve logs. I have mine stored in a folder, in this folder here. And if I want to retrieve the, logs, to say I needed to provide that to someone, that all that information would be stored in this log. So every meter that you pull creates a folder, and there's a name associated with the ID of the meter. And so as you can see, there's unique names for each folder. I'm trying to find the one I looked at this morning where we did a download, and there's two of them here, but this is the one right here. So here we have a waveform capture, historical. Let's see, that's not it. I think this is it. So this is the 1500 plus meter, and in the historical logs, actually I should go back. In the logs itself, this is where all the transient waveform power quality information is stored. So that's a good place. If you're looking for where the files are, you can go into the File Explorer, find the location of the path, and you can open up that file. Another thing that we could look at, we talked about the alarms and the harmonics. We could take a look at that. So let's go to the alarms. So this is actually very good. I was hoping to show something that there was some red in there, but basically according to the limits that we set up in the programming, the meter's within limits. So it says 123 volts. The set points are 144 and 96, so it's within the limits. And so all of the currents and so on are well within the limits. So everything comes up in green. If they were outside of those limits, you would see red highlighted in these columns. Okay, so we're going to exit at this point, and we're going to connect with the browser. So I just had a shortcut that was created that I could connect up to the meter. But basically, you would enter my Nexus or your meter, I should say IP address in the URL field, port number if you have to put one, a TCP port number, and you would connect up to the meter. This meter is assigned this port, and so when I entered in the IP, and this is a DNS name here, I was connected directly to this meter. So basically, you're going to see the same things that you would do if you were looking at the polling screens, but this just gives you the flexibility that you don't have to be connected to the meter with Communicator. You could sit at your desk and you retrieve the information and look at it real time. So this, because of the web server that this meter it's installed in this meter, you have a very good view of what's happening, and you could just keep the screen on. This meter does not have password turned on. Actually, it does, but I don't believe that you need to have the password to view this information, just read only. So, but basically, you can view each of the screens, power quality, pulse accumulations, inputs, meter information. You get all this information from the meter. You can set up emails, and your emails would be as they were set up in the. We didn't go over that in the profile, but you would see them populate in here as they would come in, as the notifications would come in. You have diagnostics. You could see the firmware version, system, firmware, memory, CPU, and so on. So you get a lot of information from the web server. And again, it's just another nice way to be able to look at the meter and without being directly connected over with Communicator. And I think we've covered the subject in as short a time as I think we could get this done. But it really is a lot of information, and each subject you really need to spend time setting it up, going into the meter, and try and create your own triggers and have it respond, and that you get a good idea how it works. And having I think after that, I think we're done, and at this point we're open for questions.